General method for addition of rational numbers. The addition of rational numbers will be done by using these four-step procedure. And in step 1, we are going to convert all numbers in the given question to their equivalent fraction. In step 2, we are going to find common multiple of all the denominators, and in step 3 we will find cofactors of every denominator for LCM and multiply the cofactor with the corresponding numerator, and in step 4 we will add all the numerators with common denominator, which is LCM. So let's get started. Step 1, let's take a look on the numbers given in question, and let us convert each one of those numbers to a simple fraction, because ultimately all rational numbers can be converted to simple fractions. So therefore we shouldn't have any problem. So 2 over 3, 2 over 3 is already a simple fraction. So this is, what is P here? P is equal to 2 and Q is equal to 3. Q is not equal to 0. Perfect. It just perfectly fulfills all the requirements for this number to be a rational number. So this is a rational number. And let's take a look on the next number, which is given in the question, that is 3 whole 1 over 6. As we can see, this is a mixed fraction, and we can convert mixed fractions into simple fractions by adopting this procedure, that we multiply the denominator with the whole part and then we add the numerator, which is 1 in this case. So therefore we will have 6 times 3 and then plus 1 divided by 6. So this way we get 6 times 3 is 18, 18 plus 1 is 19 over 6. There we go. This is again a simple fraction in which P is equal to 19, Q is equal to 6 and Q is not equal to 0. Perfectly fine. This mixed fraction also fulfills all the requirements for this number to be a rational number. So far so good. Next is minus 1.3, and this is a decimal. In order for a decimal to convert into fraction, the procedure is really simple. Draw the line below the number and then write 1 just below the decimal point. And then for every decimal on the right side, just put 1 0. So there is only one decimal on the right, only one digit on the right side. So there should be 1 0, and take away this decimal. This will give us a simple fraction of 13 over 10. And this, what is P in this case, is 13, Q is equal to 10, and Q is not equal to 0. Perfectly fine. So this decimal can also be simplified into a fraction, and it perfectly fulfills all the requirements for this number to be a rational number. So we got it right. The next number is recurring decimal, and what is that? 2.67, and 7 is the recurrent part. So we are going to separate 2 from this for now, and then we will add this 2 at the end. So what is the decimal part of this recurring decimal? So this is 0.6 bar, which means 0.67667 and on and on and on. Now, the way we can convert, if this recurring decimal is a rational number, we definitely should be able to express it in the form of P over Q, because that is ultimately the condition for any number to fulfill if that number requires to be named as a rational number. So let's name this as x. If this is x, then I actually in one of the videos I kind of illustrated this rule how to convert recurring decimals into fraction. If you have two digits repeating like 6 and 7, then you multiply with 100. If you have one digit repeating, you multiply it with 10. If you are in the question, if three digits are repeating, then multiply it with 1000 and so on. So if one digit repeat, multiply by 10. If two digits repeat, multiply by 100. If three digits repeat, then multiply by 1000. So that's the procedure. So we have done this part. Now because there are two digits which are repeating, so we are going to multiply it with 100 on both sides. So this will be 100x equal to 100 times 0.6767 and so on. So this will be 100x equal to, if we take a look on the this multiplication, because of this multiplication of 100, the decimal is going to move two digits toward right. So this would become 67.6767 and so on. Now here we are going to separate this 67 and this decimal part. So 100x, it's perfectly alright to write this fraction in decimal in this way: 67 plus 0 point or just 0.6767 and so on. If you take a look, this part was named as what? This part was named as x right here. So we can still name it as, replace this 0.676767 and so on with the same name. So 100x is equal to 67 plus x, and now take away x on both sides, minus x, this would be 99, x equal to 67 because this will cancel out. So what is it will leave us behind is x equal to 67 over 99. Now don't forget that 2 which you separated right here, we separated this 2 from here. So that has still to be taken into account. So this would be, so 2.67 bar is in fact equal to 2 plus 67 over 99, which of course can be written as 2 whole 67 over 99. And if we were following along, you saw that how we convert improper fractions into fractions. So this will multiply it with 2, and then we will add this numerator. So 2 times 99, and then add 67 to it and write the denominator 99. This will give us 2 265 over 99. Now we have all the numbers which in the form of simple fractions. So let's write, we pretty much completed step 1. So now we are going to write their equivalent fraction. 2 over 3 plus, what was this, 19 over 6 plus, oh sorry, minus, so we're going to take away this sign here. So this is view and then full page. Oh yeah, this is minus 13 over 10 plus this is 265 over 99 and then plus 5. 5 can easily be written in the fraction because there is always the denominator 1, so this would be written as 5 over 1. So that completes our step 1, and in the next step now we are going to find the least common multiple of all denominators. So what are the denominators? The denominator is 3 and then 6 and then 10 and then 99 and then 1. So let's get started to find the common denominator, least common multiple for these numbers, and we are just going to use this right pen in so that our original question is not messed up. Let's draw the line and write down these numbers separated by comma or something. 3 dash 6 dash 10 dash 99 dash 1. These are the numbers for which we need to find out least common multiple. Now the method I use for least common multiple is pretty simple, and if you follow along, so that's how you write all the numbers for which you want to find out the least common multiple, and on the top of this just write first few prime numbers. What are the prime numbers? 2, 3, 5, 7, 11, 13 and so on. For now these are enough, and if we need it, we know that we can go onward after 13. But let's take a look on all these numbers for which we need LCM, and if we'll start with the first prime number, which is 2. If there is any number in 3, 6, 10, 99, 1 which is divisible by 2, I mean if any number is even, we will always start with 2, and if there is no, then we will skip and we will start with 3. So we can see a couple of even numbers here, so we are going to start with 2. 3 is not divisible, so we are going to write 3 as such. 6 is divisible, so we will write 2 3 times 6, and then 2 how many times is 10? 2 5 times is 10, and then 99 is not divisible, so 99 dash 1, and none of the numbers now is divisible by 2 anymore. Therefore we skip to the next prime number, which is 3. I can see there are few numbers which are divisible by 3. Of course this first number and second number. So 3 and 3 one time 3, 3 one time 3. 5 is not divisible, so we are going to write 5 as such, and this will be 33 dash 1. I can still see that there is at least one number which is further divisible by 3, so we will continue to use 3 at one more time. 3 and then 1 dash 5, because none of these is divisible by 3. So here we have 11 and then 1, and this time now none of the numbers here is divisible by 3 anymore. We will skip to the next prime number, and which is 5. So 5 is, there is only one number that divides 5, 1 1 dash 1 dash 1 dash 11 dash 1. So, and the last prime number to be used is of course 11, and that will give us all of these ones. When you got all of these ones, then the product of all these numbers on the side is definitely going to be the least common multiple of all those numbers 3, 6, 10, 99 and 1. So what is this number? If you multiply 2 times 3 times 3 times 5 times 11, 3 times 5 times 11, the answer, use your own calculator while you are watching the video. You can pause the video, and this is going to be 990. The product is going to be 990, because 2 3 times 6, 6 3 times is 18, 18 5 times whatever time 11 is going to be 990. So we completed in fact the second step. Find the least common multiple of all the denominators. So that LCM is equal to 990. Now we will do one more thing here before let's create some space here. So LCM is 990. What is the first denominator? The first denominator is 3. So 3 multiplied by what is equal to 990. This number, if you divide 990 by 3, this number would be 330. 330. That's called the cofactor of 3 for 990. So this is cofactor for 3. Like 3 is one factor, and by cofactor mean that other number which we will multiply with 3 and it will become equal to 990. For 6, what is the number that we multiply with 6 and we get 6 multiplied by 165. 165. 6 multiplied by 165 is 990. You can simply find out this 165 by dividing 990 by 6. That will give you 165. And what is the next number? The denominator is 10. So 10 times 99 is equal to 990. So what is for 99? For 99 we want to make it 990, so this would be 10. And for 1, what is that we multiply? If we multiply 1 with 990 to make it 990. So we now found all those cofactors as well, which we needed to multiply with the nominators. So for 3, what is the cofactor and what is that we are going to multiply now? So 2 times, 2 times we multiply the cofactor, and that is 330 divided by 990. We are going to write the common multiple. Plus 19. 19 should be multiplied with what is the cofactor for 6? That's 165. So 165 times 19 over 990. Plus, what is for 10? For 10 it's 99. So 13 times 99 over 990 plus for 99, what is it, 10? So 265 times 10 over 99, 0 and plus 5 times 990 divided by 990. There we go. Now use your calculator and multiply all these numbers in the numerator, and we will have 333. So this will, on multiplication, this should give us 660. 660 over 990 plus, what is 165 times 19? That is 3135. 3135. And I think we were supposed to put a negative sign here, and we just didn't, we forgot about that. Okay, 3135 divided by 990 minus 13 times 99, that would be 1287. 1287 over 990 plus, and 265 times 10, that is 265 and one more 0 and divided by 990, and then plus, what is the last one, that is 5 times 990 should give us 4950. 4950 and divided by 990. So we have completed the step number 3 as well, and now we are going to add all the nominators with one common denominator, and that would be 990. And here we have 660 plus 3135 minus 1287 plus 2650 plus 4950. And now if we add this number, this number, this number, and this number, that should give us 11,395. That will give us 11,000. So 4,000, 2,000, okay, 11,395 minus 1287 over 990, and that will give us 10,108. 10,108 over 990.